Okay, so for this equation, we're going to be learning a little bit about matrices. For this equation here, we have 1, 2, 3 unknowns. Now, normally when we talk about algebra, if we have something like x plus 4 equals 10, what we want to do is we want to solve for our unknown, which in this case is x. Now, we can probably do this one in our head. What plus 4 is 10? We know that x equals 6. So that one is a very easy equation to solve. It has one variable. When you have something like x plus y equals 10, there's two unknowns. And this equation by itself is impossible to solve because there's more than one answer at any one time. If I give you y is equal to 4, then you can solve it. Then there's one value for y when there's one value for x. So essentially, when I have two variables, I need two equations in order to solve that variable. So there is equation number 1. If I have a second equation, equation number 2, where it says, well, 3x plus 3y is equal to 30, at that point, I can now solve this equation because I have two equations with x, two letters that I need to solve for, and two different equations with two different answers that I can now put together and figure it out. Now, when you have two equations, there's multiple ways of figuring that out. Later on, we're going to learn the algebraic way, but what I want to do today is show you a method referred to as linear algebra, or more specifically, matrices. Now, the difference between matrices and linear algebra is more theoretical than anything else. We're just going to call them matrices. Essentially, this equation up here, we have x, y, and z, which is three variables. How many equations would I need with answers to be able to solve an equation with three variables? 3, because here I have two variables. I need two different equations in order to solve it. If I have three variables, I need 3 minimum equations to solve it. 4 variables requires 4 things. Now, solving two equations usually takes about a quarter of a page or a third of a page of math to figure out how that works. You have to solve for y and substitute it in, and it's a little bit of algebra there. We'll learn that a little bit later. I'm going to show you a different way of writing things that's kind of a shortcut, okay? So instead of doing something simple, we're going to go straight to the hard part. And again, I'm going to be very, very general in what I'm doing here. I'm just going to show you a pattern here. Here's a matrix. A matrix is something with square brackets, and instead of writing x, y, and z, we're going to put it into a database or a different format that's easy for calculators and computers to read, okay, essentially. Okay? So computers don't like numbers, but they don't necessarily like letters. But if you see here, all the first columns here are x's, and all the second columns here are y's, and all the third columns here are z's, and all the fourth column here are answers. So essentially we have a pattern here where I could actually write -4, -3, -5, and since we know that the first column is x's, we'll just leave it as x's. And the second one would be 6, 7, actually it's going to be a -7. Why? Because it's -7, and 9. And my third column, which I'm going to call my z column, would be 8, -2, and -1. Now, there's no math here, right? All we're doing is rewriting the question, but now we're putting it into a matrix form, okay? Now, this matrix has dimensions. It is 3 by 3, okay? So it's a 3 by 3 matrix. There's 9 numbers there total. Now, this other thing, the answer here, also has an answer matrix, and I'm going to keep that separate. Okay? And the answer matrix is simply 40 and -61 and 98.
This is called a matrix format?
This is a matrix, and this is a matrix. Okay? I'm going to call this matrix A, just so that we keep them simple, and call this matrix B, just to keep it simple. Okay? Now, we have to figure out how to put these matrices into our calculator as well, and I'll show you that. It's really, really easy as well. But essentially, Kramer's rule comes up to the fact, again, I'm oversimplifying everything here. Kramer's rule says, well, these things have the x, y, and z in them. What we want to do is we want to reverse that and get the letters x, y, and z out using these numbers. Now, if these numbers change, then the x and y's will change as well. But essentially, when you want to reverse the question and come up with a solution. And so the solution will have how many different elements to them? What are we looking for here? Well, we've got an x, y, and z. So if we were to solve these two things, put them together, we would get how many answers at the very, very end? How many numbers are we looking for here? Three, right? And so the first answer that would come out would be the x, the second answer that would come out would be the y, and the third answer that would come out would be the z. Okay? Now, if you were to imagine an answer popping out of here, and you had to write that answer in matrix format, and you just learned this like 30 seconds ago, how would you write the answer? Let's say the answer is 5 for x equals 5, y is equal to 6, and z is equal to 7. I don't know what they are yet. We'll figure that out. How would you, if you had to write it in matrix format, how would you express your final answer? Well, you'd have a square bracket, right? How many answers are there? 3. So how would you write 3 numbers in a square bracket? How did we do it before? Going down. And so x would be the first number on the top, and then y, 6, and then 7, if those were 3 answers. Okay? Well, people that invented this matrix system, it's a whole bunch of math, and we're not going to, very briefly, this is their introduction to it, so very briefly, what they've discovered, and this is one of the Kramer thing, is that if you reverse the question, if you do the question backwards or inverse the question, and you multiply it by the answers to these solutions, okay, the answer matrix B, then what will pop out is the actual answers for x, y, and z. So you're going to solve 3 equations simultaneously all at the same time, and our calculator is going to do that. How does that work? Well, in order to reverse here's our unknown x, y, and z columns, x, y, and z. Well, we have to reverse the question and leave the answer. And then at the end, we'll get the x, y, and z matrix over here. So we'll call our answer matrix. So this is going to be equal to our answer matrix, which is going to be C. How do you do that? Well, here's how you do it. You take A and you inverse it. Here's the important part. You inverse it, and inverse on the calculator is -1. And then you go with B, and you get your C matrix. So we're just going to do that now. There's a way of doing it on paper, how to do an inverse matrix, and it's kind of weird. We're not going to learn how to do that on paper yet, but we're going to learn how to put these numbers into the calculator in the matrix format. And it's really, really simple, so I'm going to pull up my calculator right now, and we're going to use the matrix button right here, and we'll turn it on, and I'm going to go second function matrix, and I'm going to go over here to edit, and I'm going to edit matrix A. Now, matrix A is a 3 by 3 matrix, so you have to specify that, and then once you do specify that, it puts in all 9 boxes for you. Okay? And then we know that the very first row is going to be -4, -3, -5, -4, -3, -5. I've already pre-filled my answers, or my questions, rather.
So,
And then B would be 6, -7, and 9.
so what do I do with A, matrix A?
So you have to go and edit it and specify how big matrix A is. And ours is a 3 by 3. The question, so we're doing the question matrix. We're going to call it A. Oh, sorry, you need a calculator?
Where is the edit button on this geology?
You have to scroll over at the top here.
Oh,
Here, sorry. Do I have another color one?
That's fine.
The color one has a little bit more advanced matrix functions on it. So
Thank you.
they both work. This has been around for a while. Okay. And then, of course, we're also going to have to enter matrix B. Okay, so once you have that in, you can second function quick get you back to the home screen, and then we're going to go into second function matrix and go down to B, scroll over to edit, down to B, and that matrix is a 3 by 1 matrix. Okay, it's 3 rows by 1 across. Okay, so matrices are always measured rows first, then columns. Okay, so this is a 3 by 1 matrix, and of course it would be 40, -61 rather, 98. 40, -61, 98. So all we've learned really is how to punch in, like a bunch of rows in columns and rows, right? It's almost like a spreadsheet, but not quite. Second function quit. Now, the numbers are stored in the calculator, and now all we have to do is have the calculator calculate matrix A, reverse it or inverse it, multiply that by matrix B, and this is referred to as Cramer's rule, and the answer will give us matrix C, which is going to be our answers for X, Y, and Z.
So, did you say we multiply matrix A and B?
Multiply the inverse of matrix A with the regular matrix B. So it's inverse A times B. How would you type that in? Well, you go second function matrix, you go A, okay, so it actually says square bracket A, and then you inverse it with the inverse key. Now, everyone knows the inverse key here is this. Usually that means you flip it upside down, but we're talking about a different math altogether, okay? So it's inverse, which is a different thing when you're talking about matrices. And then you go second function matrix, and you want matrix B now. So your calculator should look like that. A in square bracket, -1, B. And the answer, if I hit enter, should be 3 of them.
So can you show me again how to put?
Okay, you're gonna have to review the video because we're rolling here, right?
All right, sorry.
So the answers here are -1, 10, and -3. Which one's which? X is -1, Y is 10, and Z is -3. We solved 3 equations simultaneously in, well, this would normally take about a page and a half worth of work, okay? But we just solved everything here in about, if we know what we're doing, we could probably do this in about 10 seconds, okay? So that's essentially how you do the matrix. This matrix here will be -3, -8, -4 for the first column, -9, -1, 7, 6, -5, 2. There's your matrix, 3 by 3 matrix. That would be A. Now, it doesn't really matter whether you could call B or anything else, but we're using A for the question, and then we're have to do the inverse of A, and then you multiply by your answers over here, okay, your equals matrix, which would be a 3 by 1 matrix. And according to Cramer's rule, the inverse of A times B matrix will give you your answers for X, Y, and Z. Now, the only trick that you really have to, it's not a trick, the only thing that you could really mess up on is not everyone writes X, Y's, and Z's in the same order. So if you have X and then Z and then Y, well, it doesn't really matter. You just have to make sure that all the X's are in the one column, all the Y's in the other column. So if I mix them up, and I think I have on this sheet, just to make sure that you're paying attention, and all the Z's, just make sure that they all line up. It has to be a pattern. It's computers like math is all about patterns, and computers like patterns. If you screw up the pattern, then it's going to have a hard time figuring out what that pattern is. Okay. So now, this is not really an assignment. I did want to go over that. I will have a couple questions here on tests or quizzes. The answers on the back. We got the right answer for question number 1, -1, 10, and -3. The answers here will be for X, Y, and Z, X, Y, and Z, X, Y, and Z. They're all there. Okay? And so what I'd like to do, I'm going to turn off the recording right now because we're getting into 13 minutes. But what I'm going to do is, try question number 2 and see if you get X should be, according to the answers, -4, Y should be 11, and Z should be 7 for question number 2. See if that works out. And just make sure you write down how to do this on your calculator, or do it a couple times on your calculator, because you will come up with a question with that. It's going to be really simple, worth 1 point or 2 points on an exam, but it should be something pretty easy. This is not going to be the focus of our course, but it's just something extra. Just like last Wednesday we had something weird. There'll be 1 or 2 questions on it. We're covering all the little details that we didn't manage to cover first semester.